Hello everyone and welcome back to the GoFr channel. I am Divya Darshana and in today's video, we'll explore how to write gRPC servers in Golang using GoFr. If you are new to gRPC, well, it's a high-performance framework that enables applications to communicate over network using remote procedure calls, that is RPC, with data serialized in a lightweight binary format. Unlike REST, which typically relies on HTTP 1.1, with text-based formats like JSON or XML, making it easier to debug but slower and larger in size, gRPC uses HTTP 2 with protocol buffers offering smaller payloads, faster serialization, and more efficient communication. To dive deeper into the underlying transport mechanism and use cases, check out the articles linked in the description below. Now, if you're writing gRPC services in plain Golang, you'll typically need to define your proto files, then generate the protobuf code. But you would have to implement observability and add health check endpoints for service resilience manually. However, with GoFr, we eliminate this boilerplate for you. GoFr allows you to register gRPC servers with built-in health checks and observability support, giving us the complete visibility into our services right out of the box. In this video, we'll walk through how to generate gRPC servers with GoFr and leverage its observability and health check features, making our services production ready with minimal effort. So let's not waste any more time and let's get coding with GoFr. So we'll start with setting up a gRPC server from scratch. Let's begin by creating a new project directory. Let's say server. Inside this directory, we'll define a proto file, which is the heart of any gRPC service. In this example, we'll name it greet.proto. A proto file is a schema definition file used in gRPC where we define the structure of our data and service methods using protocol buffers. Once the proto file is ready, we need to generate Go code from it using protocol buffer compiler. This proto compiler converts the proto definitions into Go structs and service interfaces, making it easier to handle binary serialization and RPC calls in Go. To generate the Go code for a gRPC service, we simply run the following command by providing the output path as well as the proto file path. This command generates two files, greet.pb.go and greet.grpc.pb.go. These files contain the auto-generated code to perform gRPC calls. However, one thing to note is that this code does not automatically support observability or health checks, something that is very crucial for building production-grade microservices. This is where GoFr steps in. GoFr has always treated observability as an inbuilt feature even in gRPC services. And to get started with it, we would need to install the GoFr CLI by running go install gofr.dev/cli/gopher@latest. Next, we navigate to our server directory and execute the command gofr wrap grpc server. We give the proto file path, that is greet.proto. This command generates multiple files including greetserver.go. Please note that these generated files are always present in the directory of the proto file itself. The only file that we are supposed to modify is greetserver.go. This file has a template for our gRPC server implementation already wired with context support, observability hooks, and health checks. Here we'll keep things simple, receiving a request with user info and binding it in our defined user info message type in gRPC, and then returning a single message as hello and the first name that we received in the user info. Now in a main.go file, we'll import the package where a greetserver.go is present and register our gRPC service with GoFr as server.register greetserver with GoFr and pass the arguments as app and server.new greet GoFr server. If we look at the structure of our gRPC handlers, we can find GoFr's context available there. This gives us seamless access to connected databases, metrics, logs, and traces. So we can easily add custom observability as well as perform DB calls inside our gRPC handlers. Moving on, let's run our server and then go to Postman and call the method sayHello with all the user details. Coming back to the terminal, we can see that GoFr automatically logs the request. But that's not all. GoFr also provides built-in metrics. We can access them at localhost 2121/metrics endpoint. Additionally, all the inbuilt as well as custom traces are visible at the trace exporter that we had set up, in this case being tracer.gopher.dev. For added resilience, GoFr also adds a health service for every gRPC server. This can be accessed through the health field in the generated struct. Health checks are automatically registered for both the overall server and the individual gRPC services. These health checks are extremely useful in Kubernetes health checking of a gRPC server. Moreover, to explore more about health checks and observability in gRPC, you can refer to the examples in a GoFr's repo at github.com/gopher-dev/gopher and also check our official documentation at gopher.dev. If you found this video helpful, don't forget to like, subscribe and share it with your peers. Drop a comment below with your thoughts and I'll see you in the next one. Until then, happy coding with GoFr.